Good evening to the students of Standard 12. Today we shall understand the concept of potential energy. If you remember, in the first video of this chapter, I had made you understand the difference between potential and potential energy. Simple, you keep in your mind, for potential we require the value of one charge because the other charge is 1 coulomb. For potential energy, we require the values of two charges, that means we have two charges in Q1 and Q2. This much if you remember, then you will understand the difference between the question of potential and potential energy. So keep watching this video till the end so that you understand potential energy for different configurations of two charges, three charges, four charges, multiple charges. Okay. So now let us first go back to the revision where I said just now that what is potential energy? Potential energy is charge into V, which is equal to the work done. So work done is stored in the system of those charges in the form of potential energy, which is given as QE. This much you remember because our full concept today is depending on this concept that the work done in bringing the charges is the potential energy stored, which is equal to QE. Now let me consider two charges, say Q1 and Q2, placed at infinity. Okay, so what is infinity? Infinity is the point or the space or the area where there is absolutely no potential or potential energy due to any of the charges. Okay, so let us place Q1 and Q2 at a point of infinity. From there, I want to shift those charges to the configuration such that from a particular origin, I have a charge Q1 which is at the position vector R1 from the origin, and I place the charge Q2 at a position vector R2 from the origin. This is what I want to do. I want to shift the charges Q1, Q2 from infinity to the position vector R1 from the origin O for the charge Q1. Want to shift Q2 to the position vector R2 from the origin O. This is what I want to do. For that, let me bring the first charge Q1 from the infinity. Now, if you understand how to associate this word associate is used in the questions. Associate means bringing the charges to a given configuration where I want it. So let us first understand how to bring two charges, and three charges and four charges will become easier. What I have to do? I want to bring Q1 and Q2 to Q1 at R1 arrow, Q2 at R2 arrow, that is the vector R2 arrow. They are the position vectors. Okay, where R1 and R2 are position vectors from origin. Okay, so I have written what I want. So for bringing the charge Q1 from infinity to the position vector R1 from the origin, let me just consider a point P somewhere here in space, such that the distance between the charge Q1 and the point P is R1P. This is just a random point. in space such that I can name the distance between Q1 and the point P, which is R1P. So what is R1P? R1P is distance between P and the charge Q1 itself. Fine, that is R1P. Now, I am bringing it. So, do I need to do any work? At present, it is an empty space. Nothing is there here. No configuration is there here. From the infinity, I am just lifting one charge Q1 and bringing it to a point such that the position vector is R1. Do I need to do any work? There is nothing. So I don't need to do any work. So what is my first point? In bringing Q1 from infinity to R1 position vector, no work is to be done. Okay, so now I have brought it. Q1 is here. Now here when the charge Q1 came from infinity via P till the point Q1, here it will produce its own potential as usual. So Q1 will create its own potential. Q1 will have its own potential. Where? At R1 from origin. Correct? What is that potential? V1 is equal to K. Q1, it is Q1's potential, so Q1. And what is the distance I just now mentioned? R1P. The distance between Q1 and P. So this is the potential Q1 has created when it came at this position. Now I will bring Q2. So when I am bringing Q2, I am lifting Q2 now. Q1 has already come here. Now while lifting Q2 from there, I will have to do work against the potential of Q1 from R2. I want to bring it there. So I want to lift Q2 till here. I want to lift Q2 from infinity till here. But this potential is available here. We have already read that for a point charge, one potential will be in the concentric circle. So this charge will face the potential of Q1. So work has to be done. How much work has to be done? That work which has to be done, let us name it as W1. What is W1? Work on Q2 is equal to Q2 times V1. Q2 times V1. Why? Because the formula of the work done is Q times V. Which V? V1. Which charge? Q2. Understood? So, I am bringing Q2 in the potential V1. So, how much work I should do? Q2 times V1. Simple. Agreed? Bringing Q2 in front of V1. Simple word. So, work is Q2 V1. So, now what should I write? This work done is stored in the form of potential energy. So, U is equal to stored work done, which is equal to Q2 times V1. What is V1? KQ1 upon, now I cannot write R1P. I have to write distance between Q1 and Q2. How much it is? R12. So I am writing here R12. Agreed? So let me write it in proper format. KQ1, Q2, R12. So what is R12 here? R12 is equal to distance between, I am writing in short, between Q1 and Q2. Agreed? So, U, potential energy for this system of charges Q1 and Q2 is K Q1 Q2 upon R12. Agreed? Okay, so I have to bring one charge. While bringing the first charge, remember, I don't have to do any work. That's why I did not use this formula QV. Directly I wrote V. After coming to that position, it created its own potential. See, this concept of bringing two charges, you remember and understand. Then it is very easy to bring three charges. Very easy to bring four charges. Very easy to bring all the charges. In external field also, this now I am bringing without any external field. There is no external field here. What? No external field by any other configuration. In the next topic, we will bring charges in external presence of external field also. That time while bringing the Q1, we will have to do work. Now nothing was there, it was empty space. So while bringing Q1, no work we did. Agreed? Followed? So U is equal to K Q1 Q2 upon R1 2 is the potential energy to associate a system of two charges Q1 and Q2. Simple, where R12 is the distance between Q1 and Q2. Okay, now Q1 and Q2, if both are positive or both are negative, then they will be greater than 0. The force between them is repulsive. So U is also positive. Work done is also positive. Agreed? Okay. Now, if Q1 is positive and Q2 is negative or vice versa, then Q1, Q2 is less than 0. If Q1, Q2 is less than 0, then how are these forces? Attractive between them. So, the energy stored is negative, the work done is also negative. Agreed? Okay. What is the meaning of work done is negative? We are working against the force. That's it. The displacement and the force are opposite to each other. Then work done is negative. This we have learned in 9th standard only. Correct? Okay. So, whether the force is attractive or whether the force is repulsive, electrostatic force between two charges is conservative. What is it? Conservative. What is this force? This force between Q1, Q2, whether positive or negative, force is conservative. Okay, if it is conservative, then we will get the same answer whether we are bringing Q2 first or Q1 first. Doesn't matter. Okay, so Q1, Q2 sequence, no matter, doesn't matter. Agreed? Whether I did this in this explanation, I brought Q1 first. I can bring Q2 also first. Why? This is again assertion reasoning. 1 marker. Because the force is conservative, I can bring either Q1 first or Q2 first. My answer will remain the same. Why? Because the force is conservative. Electrostatic force is conservative. Agreed? Followed? Okay? So, just understand this procedure. Then the other two procedures of bringing 3 charges instead of 2 charges will become easier. Then we don't have to follow all these steps. We can directly write. We know that the potential energy for system of 2 charges is this much. For the line joining Q1 and Q2. So we just have to add them up. That's it. By superposition. Okay. Algebraically we have to add them. Okay. I'll just move to take a pic of what we have done. What word is used other than potential energy of a system of charges? Associate. What is the energy to associate these 2 charges? That is the question used. Now let us go to the next page where I have made ready the system of 3 charges. First, where are the 3 charges? They are also at infinity. And then one by one we are bringing those 3 charges. So while bringing Q1, no work. Agreed? But after coming at this position, it will produce its own potential. Agreed? Okay. So let me name this as R12, R23 and R13. These are the distance between the respective charges as I have named them Q1, Q2, Q3. Okay. So while bringing the first charge Q1, no work. To be done. Then Q1, what does Q1 do? Q1 gives its own potential V1 at this position. Agreed? Then what is the potential when I bring Q2? Potential energy when I bring Q2. So while bringing Q2, I have to do work on Q2. How much? Q2 times V1. So what is that answer? Q2, Q1, K. This already we know from our previous description. So this is the work done while bringing Q2. So work on Q2. Now when Q2 came here, when Q1 came here, it produced its V1. When Q2 came here, it will produce its V2. So when I am bringing Q3, I have to do work on Q3 against V1 also and V2 also. Okay. So what should I do? Work on Q3 is equal to Q3 times V1 plus Q3 times V2. Okay. So what is my answer? V1 I know. V2 also I know. Agreed? So I just have to join them because we already know the formula. I have to join. So I have to just write K Q1 Q3 upon R13 plus K Q2, Q3 upon R23. Agree? Needless to write what is V1 and V2. If you are getting some doubt, you can write V1 and V2 also. V1 is equal to K, Q1, R1P. V2 is equal to K, Q2, R2P. But why to make it complicated? Just write V1, V2. So, when it comes to that configuration, I must change it to R13 and R23. Agree? Okay. So, what is my answer for U? U is equal to, for the system of associating three charges, what is the potential energy? It is the work done, stored work done is kept or stored in the form of potential energy. How much? K, Q1, Q3 upon R13 plus K, Q2, Q3 upon R23. I can write it as R32 also, both are same scalars, plus this charge, this potential energy K, Q1, Q2, R12. Okay. So what would I have added? This work, here I have put, and this work I have put here. I can change the sequence. I can bring Q3 first, I can bring Q2 first, I can bring Q1 first. But whichever charge I am bringing first, on that charge I don't have to do any work. After coming at that position, it will create its own potential. That's all. Agree? Why I can change the sequence of bringing Q1, Q2, Q3? Because the force between the charges, whether positive, whether negative, whether attractive, whether repulsive, is conservative. So I can change the sequence. Agreed? Okay. So U, potential energy for system of three charges associating. What word it is used? Association also is used. Okay, association of system of three charges. That is a question asked. One more tricky question is asked. What is the energy used to dissociate? What your answer will be? Same U, but instead of writing U, I will write negative U. What is this? Dissociation. Means separate. Already system of these three charges is there, I want to separate them. Then whatever answer I will get for association, I have to put one negative symbol in front of it. If I get a negative answer for this, I can get a negative answer for this association. Then I have to put a positive symbol for dissociation. Simple. So for association it is U. For dissociation it is negative U. These two words you remember. Okay? Association and dissociation. All questions are from here only. Nothing. You don't have to actually go anywhere other than NCERT. Practice this theory. That's it. Definitely you will get through. At least the basic you must know. Without knowing ABCD, you want to make words. And then from that you want to make sentences. That won't work out. Learn ABCD first. Then sentences. Then essays. Right? Okay. Now let us do the same workout for system of four charges. Now I have any system of four charges. Okay. What is the distance here? R12, R23, R34. For 3 also I can write. Why? Because it is a scalar quantity. but it is a distance. It's not having any direction. I have not drawn any direction. So I can write 1, 2, 1, 3. I can write 2, 1, 3, 1. You see, right? Okay. So now, again here, in this case, let me write an infinity. What is sitting? Q1, Q2, Q3, Q4. One by one, I will bring them to the required position I want. Correct? So while bringing the first one, Q1, I don't have to do any work. So while bringing Q1 to the required position, no work. Okay? After coming at that position, Q1 will produce V1. Agreed? Okay? That V1 we can write it as KQ1 R1P. Okay? Now, I have tried to do this on one board so that you understand the comparison. Comparison is the best way of learning. I can use another page also. I don't want to use. Purposely I don't want to use. Why? Because you can compare what is the difference between the potential energy of 3 charges and 4 charges. Fine? Okay. So now what should I do? I have to do work against V1. So work on Q2. How much is that work? Q2 V1. So what is my answer? K. Q1 Q2 upon R12. Okay. Agreed? So now Q1 is ready with V1. Q2 also came. Okay. So Q2 is ready with its own V2. So while bringing Q3 to this position, I have to do work against V1 also and V2 also. Okay. So work on Q3. How much? Q3 times V1 plus Q3 times V2. Agree? Now Q3 also came. Q3 also came. It is ready. It came here. Fighting with these two fellows. Understood? Fighting with Q1 and Q2. Done work against V1 and V2. Came to Q3. Okay. After coming to Q3, it means its own potential V3. Agreed? So while bringing Q4, work has to be done against, work has to be done on Q4 against V1, V2, V3. So what is that work? What is that work? Work on Q4. How much is that? Work on Q4. That is Q4 times V1 plus Q4 times V2 plus Q4 times V3. So what is the total potential energy? How many terms it will have? One term. 2, 3. Okay, 1, 2, 3, 4, 5, 6. 6 terms it will have. So let us write those 6 terms and add them. That is the potential energy to associate 4 charges. Okay. So now let us write the potential energy to associate a system of 4 charges, adding all the 6 terms one by one. Okay. So U U is equal to, let me write the first one. Where is the first one? This one. Okay. K Q1 Q2 upon R12 plus, what is the second one? Q3 and 1. 3 and 1 combination you remember. K Q3 Q1 upon R13 plus, what combination you have to remember? 3 and 2. So K Q3 Q2 upon R32 plus, come to this configuration, Q4 and V1. So 4 and 1. It will be easy. No need of by-hearting. I will teach you. K Q4 Q1 R14 or 41 plus K Q4 Q2 R24 plus K Q4 Q3 R34 or 43. Okay, so all the 6 terms I have written. So this is the potential energy to associate a system of 4 charges. 4 charges. This is potential energy to associate the system of 3 charges. If dissociate, they ask negative. If dissociation, they ask, this answer you find out and then write negative. That will give you the energy of dissociation, means breaking. Okay. Now to make this easier, how you will remember 1, 2, 2, 3, 3, 4, that is a confusion. So you go to the diagram. Diagram is always your friend in physics. Okay. So go to the diagram. What is our friend? Diagram. So whom you will first go? We will find out 1, 1. Now you go to this combination 1, 2. 1, 2, ready. 2, 3. Where is 2, 3? Ready. 3, 4. Where is 3, 4? Ready. 1, 4. Where is 1, 4? Ready. Okay. So you have gone to Q1, Q2, Q2, Q3, Q3, Q4, Q4, Q1. Now only 4 I have underlined. Where are the other 2? These 2. Q1, Q3. Here. And where is the other one? Q2, Q4. Here. Okay. So diagonals also you have to consider, because that potential will go through the diagonals also. Understood? Agreed? That we have already mentioned what has happened. So the potential energy for associating a system of 4 charges together is addition of potential energy between these 2 charges, these 2, these 2, these 2, these 2, and then this 2. Diagonals also. That's why you have 6 terms. Here you have 3 terms. Remember that much. That much will be enough. Okay. So there is no need of actually by hearting these formulas. Here also go 1, 2, 3. Between Q1, Q2, Q2, Q3, Q3, Q1. Over. You're done. Here 4 plus 2 diagonals. 4 sides plus 2 diagonals. You're done. This way you remember. Understood? Clear? So just now you take a pic of what we have done just now. Understand it very clearly, and it is very easy to solve such numericals also, keeping this concept in mind. That's why it is very important to read NCERT, because now you don't have to by heart anything. You know why this has happened. You know I have given you the reason. Here also I gave you the reason. Reasoning is there. Once you know the reasoning, there is no need to by heart. Otherwise, how much you will by heart without knowing the reason? Agree? Okay. So you keep these concepts in mind. that when there is a system of two charges, add. When there is a system of only two charges, then you write the formula for two charges, three charges, then combination of three, four charges, combination of four. Understood? What mistake child does? Forgets to add this diagonal. Diagonal also has to be added. And how are you adding all this? By principle of superposition. What is the method of adding? Algebraically. How can you understand it is algebraically? Because I have not considered any direction anywhere. So just algebra. If it is a positive charge, I'll write positive charge. If it is a negative charge, I'll write negative charge here, anywhere in the multiplication. Whatever I get, positive or negative, that is my answer. Clear? So I just move, you take a pic of what we have done just now. Okay? So we have come to the end of this video. In the very next video, we shall do some more concepts on potential energy and solve some numericals also. Fine? Okay?